Okay, in this lecture we're going to talk about symmetry that some functions have. Not all functions, but some special functions and relations have different kinds of symmetry according to the axes. So the first one we're going to talk about is x-axis symmetry. And you can see visually a graph that has x-axis symmetry, which is this one here. Now the reason it has x-axis symmetry is if you look at this point here, then this point here is a mirror image of that point. Alright, and straight through there we have a vertical line. And they are exactly the same point, except that this one, when it's xy, this one down here is x negative y. And you can see, of course, this is not a function here, because it doesn't obey the vertical line test. So this is not a function, and so when we're dealing with this function y equals f of x, the way we actually determine this is to say that a function is symmetric about the y-axis, the x-axis, if when we replace y with negative y, we obtain the same x value. Alright, so that's how we can actually test for it. Okay, so in other words, if the point xy is on the relation, okay, and I should say here a relation really, because in this case it's not a function. Alright, so if the point xy is on the relation, then the point x negative y is on the relation. Okay, and so we can see here that we have a direct mirror image of these points. And so the way to test for it is to replace y with negative y and see if we get the same x value. And we'll do some examples and show how to do that. Now the next one we're going to talk about is y-axis symmetry. Now in y-axis symmetry, you will notice here that if you look at this second function here, this point here and this point here are in fact mirror images of each other around the y-axis. So this point here, of course, is xy, and this point over here is negative xy. Okay? So in other words, our function y equals f of x, okay, is going to be symmetric around the y-axis if when the function contains xy, it also contains negative xy. Alright? So in this case, a function or a relation is symmetric about the y-axis if when we replace x with negative x, we obtain the same y value. Okay. All right. So again, okay, these are a mirror image of each other across the y-axis. All right. Now let's have a look at some examples. What if I think about the function, say, let's test for the symmetry. I'm going to test for symmetry with respect to the x and y axis. All right, first one. What if I have x equals the absolute value of y? All right, well, what happens if I now replace, all right, so let's first of all let's test for x-axis. Right, so we replace y with negative y. So notice here, if I take this y and I replace it with negative y, what happens? Well, this is like negative 1 times y, which of course is the absolute value of negative 1 by y. Of course, the absolute value of negative 1 is 1, so I actually get y, which of course is x. So we get the same x value. So yes, we do have x-axis symmetry. Right, now what about y-axis? Then we replace x with negative x. Okay, so if I have negative x, is this the same as the absolute value of y? Well, no, it's not, because okay, we only need to look at a counterexample. What is a value here? So let's suppose I take y is negative 2. Then x would be 2, right? Okay. Is it possible to get a negative? No, it's not. A negative x, because the absolute value always makes it positive. All right, so that's how we do that. So we don't have any y-axis symmetry. Right, let's do part B. What if I have something like y equals the absolute value of x minus 2, for example? Right, so let's again look at x-axis. Then we got to replace y with negative y. So when we have negative y, okay, this of course is equal to what? The negative of y, but I know that y is, so this would be the negative of the absolute value of x minus 2, which of course is the negative value of absolute value of x plus 2. Now you can see that these two are not equal. To do that, all you have to do is put in, say, 1, and you get minus 1 for this one. If I put 1 in here, I'll get minus 1, and plus 2 is plus 1. So I get different answers. So there's a no for that one. What about y-axis? Then what do? Replace x with negative x. So I have the absolute value of negative x plus 2 is actually equal to the absolute value of negative 1, like we did up here, absolute value of x plus 2, which of course is equal to absolute value of negative 1 is 1, so it's negative x plus 2, which of course is y. We get the same thing, so yes, we do have y-axis symmetry. All right, so let's do another one, part C. Let's suppose we have 2x, take y equals 4, for example. All right, now if, so to use, to do x-axis, then if I replace y with negative y, is what? That's going to be equal 4. This is equal to, which implies we're saying that 2x plus y equals 4. And you can see that that is different, so no. Right, 2x minus y equals 4 and 2x plus y equals 4 is not the same. So what about y-axis? Right, well, let's put in negative x, so we get 2 by negative x plus minus y is equal to 4. Does that imply that negative 2x minus y equals 4. Is that the same? No, that's not the same, so no. So it's no for y-axis symmetry. Right, and let's do one more. What, suppose I have x squared plus y squared equals 9. So now we use x-axis. So we replace y with negative y, so we have x squared plus negative y squared, of course, is equal to x squared plus y squared anyway, so that's 4, so yes. So we do have x-axis symmetry. What about for y-axis? Then we replace x with negative x. And of course we see that that's the same as x squared, and that's 4, so yes. So this one has x and y-axis symmetry, and of course this is a circle, and so you can see straight away that it does. All right, this way and this way. All right, so there's one that has both. Here's one that has none. Here's one that has y-axis symmetry, and here's one that has what did we have here? So this one was not equal for B. On this one up here we had, this one was x-axis symmetry. So x-axis, all right, y-axis symmetry. This one has none, and this one, or neither. What we say is neither. And in this one we have both x-axis and y-axis symmetry.